Hello and welcome back. Alright, so today we are going to take a look at our first sorting algorithm. Sorting is a very important thing to be able to do in computer science. It is said that sorting is one of the things computers spends the most time doing, so let's go ahead and try to figure out how to write some sorting algorithms. Now, the algorithm that you're going to learn today is extremely simple. It should also never really be written, but it'll get our feet wet and to learn into what we're going to need to be doing to actually solve sorting algorithms. So the algorithm that we're going to be learning today is called bubble sort. All right. So now the idea behind bubble sort, the idea behind any sorting algorithm is to take some set of numbers. We're going to use an array. Ooh, that's really bad. Slightly better. Um, So the idea behind any sorting algorithm is to take a set of data and sort that in some meaningful way. Usually we're talking about either words or characters, um, which already have a predefined kind of ordering process, or you can come up with your own data types that have special ordering as well. So for this example, I'm just going to go ahead and fill in some numbers here. 2, 4, 8, 1, 7, 6, 5, and 3. Perfect. All right, so now the idea is that we actually want to end up with an array with these values. So we need 1, 2, 3, 4, 5, 6, 7, and 8. Oh, look at that. Didn't even mean to do that. Okay, so this is the order which we want. So this is our goal. And this is what we start with. Okay, so now there's a couple ways that we can go about, well, there's a lot of ways we can go about doing this. The simple and naive approach is to simply start here and walk down this list and compare the item that we're on and the next item, and to see if that item is greater. To compare these numbers, and if 2 happens to be greater than this number over here, then you know what? We need to swap those. And so the idea is that we will push the biggest number all the way to the edge here. So for our comparison is 2 is greater than 4, false. Great. 4 is greater than 8, false. All right, 8 is greater than 1, true. So we would swap 1 and 8, and then we'd continue on. We'd ask, hey, 8 and 7. Oh, okay, that's greater, so swap those, and continue on. And we want to do this for as long as we want to do this while we actually have made a swap. Because if we've made a swap, then we know that there's a potential that our numbers are still out of order. The interesting thing about bubble sort, and this is actually one of its only redeeming qualities, is that bubble sort can actually determine if an array is sorted fairly quickly. Because all it has to do is make one trip down the array, and if it hasn't made any swaps, then guess what? The array is sorted. So that's really the only good thing about bubble sort. Otherwise, it's worst time. It's a really, really slow sorting algorithm. And there are a lot of other better ones. But let's go ahead and take a look at how we actually might go ahead solving this problem. Okay, so what we're going to do is we're going to create a method prototype called bubble sort. And it's going to take in an int array. We'll do a star. And we're dealing with C++, so we're going to need to know how long that array is. Okay, so now if you remember when I talked about the implementation that we're going to do, we need to know this swap variable, if it is swapped or not. Okay, so let's go ahead and create a Boolean for that. Boolean swap. And we're going to go ahead and set that equal to false. The next thing that we know is that we're going to loop through this entire array. And we also note that if we're pushing up this the biggest number to the end, our next time through the loop, we don't need to go all the way to the end because we know that's sorted. We can actually stop here. So I'm actually going to cheat, and I'm going to use n and just decrement that. We could create a copy of it if we want to. It doesn't really matter. This value is getting passed into us. We're not going to be returning back that value or modifying the value that got called, or the place that called us, so it's okay to do that. Okay, so what we need to do is we need to do a while loop. While we have a swap, we need to go ahead and continue our looping. So since I've set my swap to false, I'm going to use a do while. We know that we always want to go through our loop once, so let's go ahead and use our do while loop. Okay, so that seems pretty good. So now what we want to do is we actually want to do our first little loop all the way through our numbers. Perfect. We know how to write a for loop. So for int I equals 0, I is less than. Okay, so what do we want to do? I is less than our length of items. So we know that this array has 8 items in it. So that means n is going to be passed in as 8. However, we also know that we are going to be comparing this value with this value. So basically, we're going to be comparing I and I plus 1. Well, we do not want to overstep the bounds of our array. So what we're actually going to be doing is we're going to do while I is less than n minus 1. And then we want to increment our I counter. So does that make sense? We want to do n minus 1 here. So n's coming in as 8. So what we're saying is that while I is less than 7, for our first loop through here, less than 7. So that means I can take the values 0 through 6, which will get us from here. So 0, 1, 2, 3, 4, 5, and 6. And so that'll give us the ability to compare this one without jumping out of our bounds of our array. Okay, perfect. So now if the array value at I is greater than the array value at I plus 1, then we need to actually swap those two positions. So what we're going to need to do is we're going to need to create a temp variable to hold the value. So int temp equals array, doesn't matter which one we use, array I, and then we're going to say array I equals array I plus 1, and then we're going to say array I plus 1 equals temp. Perfect. And then we also need to make sure that, you know what, we did a swap, so we need to set swap to true. Okay. And that's it for our for loop. So now we've gone through the end of our loop for our first guy, our first iteration through here. So what we need to do is we need to decrement the end value because we know that we have successfully sorted this final the item that's going to go into the last index of our array. Okay. So we can do n minus minus. And the other important thing we need to do is we need to reset our swap value. But if we were to do it here, because remember we have a while check, we have while swap. Well, if we reset it here, it's always going to be false. So what we need to do is we actually need to change or add the swap being set to false up here. So that when we start our initial array, or walk through our array. Our swap value gets reset to false so that we do not pollute our answer. And then down here, we know that if we walk through the array and we created a swap, then we need to actually go through the list at least one more time. All right, hope that makes sense. So now there's one other caveat I want to tell you about with this method, is that this actually sorts the array in place. That means the user has passed in a pointer to this location in memory. And we are actually modifying that location in memory. So this method has a severe side effect. If the user did not want this array to be modified, we would have to change our implementation to create a new array inside here and return a pointer back to that array. But for simplicity's sake, this is what's going to happen. So let's go ahead and take a look at what happens during our first iteration through our loop. Okay, so we have, I'm going to block this part off right here. Okay, so we have swap is false. Perfect. Our integer I is 0. So our comparison between 2 and 4, we're good. Okay, so I'll draw the array right here. Oops, the array box at least. Okay, so we got 8 elements. All right, so 2 and 4, check. Those are in the right order. So I know that 2 is in the right order. So now 4 and 8 are going to be our check because I is going to be equal to 1. 4 and 8, all right. 4 and 8 are in the right order. So now we're going to look at 8. 8 and 1. 8 and 1, they are not in the right order. All right, so we already know that at this point, right here, I'll just put right here, a little arrow, that swap goes equal to true. All right, and then we're going to switch the position of 8 and 1. So I'm going to put a 1 right there. And so now we're going to be comparing, so right here through our first iteration, we're going to be comparing 8 and 7. 8 and 7, well, 8 is greater than 7. So let's go ahead and swap those. So that means the 7 is going to go here. Now we're going to be comparing 8 and 6. Well, 8 is greater than 6, so we're going to swap the 6. And now we're going to compare 8 and 5. 8 is greater than 5. I'm going to compare 8 and 3. 8 is greater than 3. And so here we go. We have reached the end of our array because we've reached the index location of 6, which is going to be this location right here where 3 is. And we know that we've swapped. So our n is going to get decremented. So our n came in at 8. Now it's going to be 7. All right, we're going to reset swap to true or to false. So we're good to go. Let's get a new array and let's walk through this a couple more times just to really illustrate what's going on. Okay, so swap is false. We're good to go. N is now 7, so that means we're going to go the index values 0 through 5 this time through. So 2 and 4, we're good to go. 4 and 1, we're not. So we go ahead and swap them. Oops. Well, yeah, let me go ahead and erase the 4 because I shouldn't have wrote that in yet. Okay, and so at this point right here, we've done a swap. So we're going to set swap equal to true. Okay, so 1 and 4, we're good. So now we're going to compare 4 and 7. All right, 4 is less than 7, so it's going to stay there. Now we're going to compare 7 and 6. Oh, well, we need to swap those. And it's going to reset swap to true, but that's fine. Sorry, I shouldn't have wrote in 7. Then we're going to compare 7 and 5. Well, 5 is definitely less than 7. Then we're going to compare 7 and 3. All right, and 8's going to stay the same. We never even compared 8. 8 just already fell in place from the previous time. Okay, let's draw this in. So I'm actually going to make that a little bit more clear that we're not even checking the last two items anymore because n, so right here, n equals 7. Oh, sorry, n equals 8. Right here, n equals 7. Right here, n equals 6. Okay, so we're going to compare 2 and 1. Oh, well, look, what do you know? Our first one already swapped them. Swap equals true. 2 and 4, so 2 is going to stay there. 4 and 6, we're good. Or 4 is going to stay there. 6 and 5, we're going to swap them. 6 and 3, we're going to swap them. And we reached our end, so 6 is just going to go right there. All right, so this is going to continue on, and we are going to eventually end up with our nice fancy array that is in sorted order. 1, 2, 3, 4, 5, 6, 7, and 8. So that right there is bubble sort. And the reason why we don't actually ever want to use this is because when we start looking at the complexity of our algorithms, we're going to find that this is going to run in what's called big O n squared time. So this means is as n goes, this the amount of time if we had a graph and this is n and this is the amount of time that the algorithm takes, we're going to see that this is an exponential curve. And we don't really want our algorithms growing at an exponential rate. What we'd really like is if we could have a constant algorithm. But you're not going to get a sorting algorithm that does that. So maybe we can get a linear, though. You're not going to really get a linear, but you could get a logarithmic growth curve, which would be somewhere in between here. And so, well, linear is going to be here. Your logarithmic curve would look maybe something like this, and then your exponential curve is going to be like this. So really what we want to go for is a growth curve that's as close to linear as possible for these types of problems. All right, so there's the bubble sort. In our next video, we'll take a look at a few of the more advanced sorting algorithms and get those underway. All right, thanks.